Hello, students of geometry. Welcome to lesson 2.8, talking about proving angle relationships. And some new terminology in this one. Really what we're going to do with this lesson here is more of just use what we see here, use these theorems, use these postulates in the context of some actual problems rather than doing the proof stuff. If you're one of my students, yes, we're going to do some proofs this year, but this really won't be the start of that. We'll be doing that in a later lesson. And make sure you use those extra examples in your book as always. So this should be pretty quick, I think. We're just going to go through 4 example problems like the ones you'll see in lesson 2.8 if you're one of my students, like the ones you will probably see on the quiz. Very, very similar problems to those right here. So let's check it out. Example 1, find the measure of each numbered angle. Here we have angle 2 and angle 3 are complementary. This means they add to 90. So I'll make a little note of that. That's 90 degrees together. And then the measure of angle 2 equals 40. Those sound like 2 pretty important pieces of information there. I'm going to label that on my picture. So since these 2 add to 90, I could say this is true. I'm going to put a little box in the corner. 2 and 3 added together is 90. And the measure of angle 2 is 40. So here I'm going to put a 40 degree label in angle 2. That should make it pretty easy, I think, to figure out what's 1 and what's 3. So we already know the measure of angle 2. So I'll just rewrite. It says to find the measure of each numbered angle, so I already know 2. That's 40 degrees. I can say that's given to me. So as I go along here, I'm going to get in the habit of giving justifications for what I'm saying. This is really the basis of proving things. So you say something and you give a justification for what you just said. So this is proven, or this is true, because it's just given to me as true. This is a piece of information I'm initially given. The measure of angle 3, I could easily find based on what I have here in the picture, what I have in the instructions for the problem, because they're complementary, 2 and 3. That means 90 minus this one would have to give me what's left over right here, that one. So 90 minus 40, and what's my justification for that? Well, they are complementary angles. That means they have to add to 90, meaning that if I subtract one from the other, it would have to give me my answer. So complementary angles, I could say that's my justification for that. And so from there, I can say clearly then that the measure of angle 3 is 50 degrees. And that's it for that one. So now I just need the measure of angle 1. So I'm going to put this in here in red. This was something that I proved was true now, so now I can utilize this information as well. And I know these two together, I already knew that that was 90. That means this one would also have to be 90. You got a linear pair right here with 1 and then 2 and 3 together. If you took that as one whole angle, 2 and 3 together, along with this one, that's what you would have to have. So I could say that the measure of angle 1 is going to equal 180 minus 90, and you could give a justification for that by saying, hey, they form a linear pair. So that would be a reason for what you just said. And then the measure of angle 1 then, clearly I think would be 90 degrees. I think that's clear that that should be the case then. So 90 degrees. So if I write that in here, I'll use a different color to say, hey, this is something I found out was true. If I add all these together, 90, 40, and 50, they should make 180 degrees because I have a straight line here. And if I add them together, I in fact get 180 degrees. So let's check out example 2 now and see what that one looks like. So this is going to be using similar information or similar types of information here, but we may be introducing or bringing in some concepts that we've already learned from past lessons as well. So in this one, I see a linear pair here with 5 and 6. I see a linear pair with 6 and the 36 degree angle. Notice no instructions given here, but we have enough information in the picture to figure these two out. And so why don't I start with the measure of angle 5. And do you remember what these kinds of angles were called? So this one, 36, and then this one, if they form those two perfectly straight lines together, they're across from each other. If you said vertical angles, that is correct. So 36 degrees, the measure of angle 5. We talked about that, my students, in a previous lesson. So that could be a justification for what you said. We talked about how vertical angles were congruent. So I could say that this is congruent to this. That means since that's 36, this also has to be 36. So based on that, we can find 6 using either this 36 or this one. We've got a linear pair here and here. with these two angles. We've got a linear pair here and here with 5 and 6. So let's just write down what I can clearly tell from the picture then. Measure of angle 6 would be 180 minus 36 because you have a linear pair. So there's my justification for what I just said in parentheses there. Now I can go ahead and say, hey, this is 144. 144 degrees, that would be the measure of angle 6. So I could write that in there, and let's see if that all seems to check out. If you add 144 and 36, that's 180, either way you look at it. So that seems to be good. If this was 144 as well, like it would have to be, because these are vertical angles, 6 and this blank one, you add all 4 of those up, you should get 360. And you, in fact, do get 360 if you do that. Let's check out part C here and see what we got for that one. So this one says a measure of angle 7 equals 2x plus 6. Okay, so let's put that in the picture. 2x plus 6. That is this angle measure right here. The measure of angle 8 is 2x minus 11. 14. I wrote it down right, but I just said it wrong. 2x minus 14. So what do I know about 7 and 8? Just looking at the picture, I think it's clear. You could say, hey, they form a linear pair once again. So I can say that the measure of angle 7 plus the measure of angle 8 has to equal 180 degrees. My justification for that, they are a linear pair. And then I could take what they equal and plug them in. If you did that right away, no problem with that at all, I would say. So 2x plus 6, that's measure of angle 7, plus 2x minus 14, that's the measure of angle 8. I'll use parentheses, I wouldn't have to, but I'm just saying this 2x plus 6 was representative of measure of angle 7. Likewise, this with the measure of angle 8. And so from there, I just am adding these two things together and not multiplying, so just combine like terms. 2x plus 2x, you've got 4x, and you've got positive 6 plus a negative 14, that's like 6 minus 14, that's negative 8 or minus 8 right there. And then I could add 8 to both sides. That would leave me with 4x equals 188. And finally, I could divide both sides by 4. That would leave me with an answer for x of 47 for the value of x. Now, what did the instructions say? If I go back to the instructions here, find the measure of each numbered angle. Did I do that yet? No. So please don't stop there. Don't make that mistake. I'm worried that some of you might make this mistake on a quiz if you're one of my students. So we're going to take this and do what with it? We got to plug it back in here and here to find the measure of angle 7 and to find the measure of angle 8. So the measure of angle 7, that would have to be 2 times 47 plus 6. And that would be 2 times 47. That would be 104, looks like. And then if I add 6 to that, I've got 110. I meant to say 94, not 104. So this would be 94 plus 6. That's 100, I mean. So 100 degrees, not 110 degrees, but 100 degrees for the measure of angle 7. And so I just took this value, plugged it in for x into there, into my original expression. Now let's do the same thing for the measure of angle 8 to calculate what that equals there. So 2 times 47 once again, that's going to be 94 minus 14. 94 minus 14, that's 80 degrees. And so we have 80 and we have 100. If we add those together, it should be a linear pair. It should be 180. And so this one is 100 degrees, this one 80 degrees. It does in fact make a linear pair. So we're pretty confident then that we did this right. Now notice the picture. On the picture here, I'm probably going to mention this. I hope to mention this in class as well. But this did not look like the bigger angle of these two. However, you need to trust the information in the picture, not the way the picture looks. So just because it looks like 8 is bigger than 7 doesn't necessarily mean it is. Pictures aren't always drawn to scale in geometry. So you can't assume something's drawn to scale in geometry unless you're told that you can. So we can't actually measure these angles with a protractor, just like we can't measure these angles with a protractor here unless you're told that you can actually do that. And then finally, the measure of angle 9 in this picture is x plus 1. Measure of angle 10 is 3x minus 141. What kinds of angles are 9 and 10? Well, those are vertical angles. So I have right here, vertical angles I know are congruent. I got measure of angle 9 would have to equal the measure of angle 10. I could put a little arc mark here and one here. These have to match up. And this is by vertical angles. And so if I plug in what I've got x plus 1 for the measure of angle 9. I've got 3x minus 141 for the measure of angle 10. Now a pretty basic algebra problem from there to solve for x. Get the x's on either side. I'm going to move mine to the right. And I'll move the regular numbers, the integer numbers in this case, to the left. Those would cancel here. The x's would cancel here. I am left with 142 equals 3x minus x would be 2x. I can divide both sides by 2 to get what x equals. This is not my final answer because I need to find the measure of the actual angles themselves, but this is a very important bit of information in order to be able to do that. So the measure of angle 9 is x plus 1. So I'm going to plug in 71 for x. 71 plus 1. That means the measure of angle 9 equals 72 degrees. So that was used right there. I'm just plugging it in for what it equals. Same thing is going to happen here. I've got the measure of angle 10. Let me box that in a second. Measure of angle 10 equals 3 times 71. Whoops, that's a bad 1 there. 3 times 71 minus 141. So 3 times 71 looks like that's 213. And 213 minus 141, if you check that in a calculator, you should get what we expected to get. These two angles are supposed to be equal. So the measure of angle 10 should be the same thing as the measure of angle 9 after we do all that information or plug all that in and work that out. And we in fact do get that the measure of angle 10 is also equal to 72 degrees. So I can look back at the picture. I could calculate this one and this one from there. I could do 180 minus 72 to get this one and this one. And again, I tried to kind of trick you on this one. Made these angles look bigger than what they actually were. So if you were to write this in as 72 degrees, definitely looks bigger than 72 degrees in the picture. It looks like it's an obtuse angle, but really trying to emphasize that in this lesson here, that don't always trust the way the picture looks. Trust the information that is given to you in the picture. I think that does it. Yeah, this was a pretty quick lesson here. We were not doing all the examples or examples like everything you see in the book there. We're just really focusing on how can we play the angle game, you might say. How can we figure out what all these angles are equal to based on the things we know, like vertical angles, like linear pairs, complementary, supplementary, knowing how to determine the measure of an angle given different bits of information like that. So if you have any questions, either comments, if you're not one of my students, or ask me in class if you are, hope you have a great day, and I'll see you later for our next lesson.